Now we can go back to the example for the measurement of the instantaneous amplitude of a sinusoid, and we can test our application example using our Hilbert transform design. We saw that the lower end for the passband of our design is at normalized frequency of about 0.05. Hence, we test a sinusoid of that frequency. So here we are constructing a sinusoid with that frequency, and it's plot here. Now we can filter it with our filter, which passes only positive frequencies, H1, and creates a complex value signal XH1. So this is we're convolving our signal with the H1, and then we're plotting the real part and the imaginary part. And here we can see that we get indeed a 90-degree phase shifted version, the red curve, about between sample 15 and 45. Now we can compute the magnitude of this complex signal XH1 to obtain the amplitude of our sinusoidal signal. So here ABS of XH1, and we have here we see that about sample 15 and 45 we obtain the amplitude of our sinusoidal signal with about 10% accuracy, which roughly corresponds to the minus 20 dB attenuation, corresponding to an attenuation factor of 0.1 that our filter H1 provides. This also hints at the fact that we can improve the magnitude estimation by having a filter with a higher attenuation at negative frequencies. But also observe that this only works for sinusoids inside our passband.